Hello and welcome back. Today we are looking at calculating with numbers on the University of Helsinki's massive open online course. And we're going to learn to perform calculations with the help of variables, know how to form printable statements including both calculations as expressions and strings. The basic mathematical operations are both familiar and straightforward. Addition is a plus sign, subtraction minus, multiplication star, and division /. The precedence is also familiar. Operations are performed from left to right with the parentheses taken into account. Expressions involving multiplication and division are calculated before those involving addition and subtraction, as is customary in elementary school in mathematics. So here we've got the example: integer with the name first is equal to the value of 2, and we've got integer with the name second equal to the value of 4, and then we've got printouts for both of those. Here we've got a new integer called sum, which is equal to the value of first plus second, so 2 plus 4, and then it will print out the sum, which is 6. You can affect the order of operations by using parentheses. Operations within parentheses are performed before those performed outside of them. So here we've got another example, so int calculation with parentheses, so we've got 1 plus 1 and 2 plus 5 plus 3 multiplied by the answer, and that prints 23. But without the parentheses it prints 13. The example above can also be divided into these steps. So by using these steps we're removing the need for parentheses, but we're making the calculation a lot longer. In the exercise template, implement a program that asks the user for the number of days. After that, the program prints the number of seconds in the given number of days. Earlier we learned to read an integer in the following manner. Examples of expected output. Okay, so let's go to Netbeans and open the seconds in the day challenge and begin our coding. So I'm going to quickly get the question details from here. Let's paste that in. Oh, that's long. Okay, in the exercise template, implement a program that asks the user for the number of days. Okay, so the first thing we need is a prompt. So system out, and in fact, let's see if they've got any specific requirements for the input. Oh, there we go. So how many days would you like to convert to seconds? So let's just copy and paste that straight in. There we go. And then we're going to need a variable to store our integer. So we can say int input, or I input, is equal to integer dot value of scanner dot next line. There we are. And then after that, the program prints the number of seconds in the given number of days. Okay. So we know that there are 86,400 seconds in one day. So let's do int 1 day equals that, and then we can do our system out. So let's see what the output is. So it's just the number. So we can say system out 1 day times I input. So let's see how we get on. I do wonder if it won't like it because, oh well, firstly because I forgot to take out the comments, but also I'm wondering if it won't like it because it was thinking of us. Oh wow, it works. Okay, that's great. So I imagined it may have wanted us to work out, you know, how many seconds in minutes, and then minutes in hours, and then hours in day, rather than just doing this sort of this way. But that's great, that works. So let's close that one and go back to here. So that's cool. So what does the program print? So we've got integer first is equal to 10, int second is equal to 10 plus 5, first equals 20. System out print second. So I'm going to go with 15. Excellent. That's great. An expression is a combination of values that is turned into another value through a calculation or evaluation. The statement below includes the expression 1 plus 1 plus 3 times 2 plus 5, which is evaluated prior to its assignment to the variable. The evaluation of expression is always performed before its value is assigned to a variable. As such, the calculation above is performed before the result is assigned to the variable. An expression is evaluated where it occurs in the program's source code. As such, the evaluation can occur within a print statement if the expression is used in calculating the value of the print statement's parameter. So very much like I did, my system.out for the previous example was the number of days, the number of seconds, times the number of days. So here we've got int first equals 2, int second equals 4, and then first plus second, so 6. And then 2 plus second minus first minus second prints 0. Okay? An expression does not change the value stored in the variable unless the expression's result is assigned to a variable or used as a parameter. For instance, in printing int first 2, int second 4, the expression below does not even work since the result is not assigned to a variable or given as a parameter to a print statement. So it's not doing anything, so it wouldn't process. So what does the following print? So we've got int age 32, height 178, and then int height equals age plus 10. And it wants us to system.out.print age, which was equal to 32. Let's print that. Excellent, so that's fine. Calculating and printing. The command system.out.print line prints the value of a variable. The string literal to be printed, which is marked by quotation marks, can be appended with other content by using the operation plus. So here's the string literal, there's the plus, so we know this is concatenation. If one of the operands of the operation plus is a string, the other operand will be changed into a string 2 during program execution. In the example below, the integer 2 is turned into the string 2 and a string has been appended to it. The precedents introduced earlier also apply here. So system.out.println 4 plus 2 plus 2, but 22 plus 2 plus 2. So let's see. So this is stepping us through the steps involved in printing the 4 and the 22 as well. So the next challenge is the sum of two numbers. Write a program that asks the user for two numbers. After this, the program prints the sum of the numbers given by the user. When you ask for multiple numbers, create a separate variable for each. So we're going to need to create at least two variables and then print them out. So let's go back to our Netbeans. So open up the sum of two numbers here. Okay, so the first thing that we need is a user prompt, so we'll do an sout, and we'll write give first number. So we'll need an integer, and we can say first input, and then that's going to be equal to integer.value of scanner.next line. Give the second number, so we need another system out. Give the second number, and then we need another int, so that can be second input equals integer.value of scanner.next line. And then the third thing we need to do is a system out, so sout the sum of the numbers is plus, and then we can do first input plus second input, like that. I'll just get rid of these. Let's give that a run and see how we do. Excellent, so we passed that first time, that's great. But there is another way. I mean, you don't have to do it exactly the way that I've done it. You could create a third variable. So you could say int answer is equal to the value, so first input plus second input, that's absolutely acceptable as well. And then what you would do down here is replace that with this, and then that will print the same thing. So that's absolutely fine as well. So let's close that and head back and see what the next challenge is. Sum of 3 numbers. Okay, let's go back to TMC. Kind of wish I copied that code before I closed it. Do I have it? No, I don't. Okay, not a problem. What can we do? We can open it, so let's see where it is. File, open recent project, sum of 2 numbers. Brill. So we can copy and paste this. Go to sum of 3 numbers and paste it in, and delete the bit that we don't need, which is the duplicated scanner, and we've already got the most of our code written for us. So let's close that. So what we need to add on is another system out. I don't know why I typed that out the long way. And presumably it will be give the 3rd number. So give the 3rd number, and then one of those, and then we need another integer. So 3rd number. And remember, this is following camel case, because the first letter is lowercase and then the first letter of every subsequent word is uppercase. So integer dot value of scanner dot next line, and then we need to update the answer, so plus 3rd number, and then oh, I forgot to put the semicolon on. There we go. So if we give that a test. Excellent, passed first time. So that was quite nice and easy. So before I close this one, I'm going to go back and see if there's another mathematical formula one. So applying this knowledge, we can create an expression consisting of some text and a variable, which is evaluated in connection with the printing. So here we're printing out the value of variable x is 10, which is this line here, y is 5 and z is 6. So here we are concatenating this string literal to this integer with this string literal and this integer, and we're getting this out here. So let's see what we need to do next. So give the first number, give the second number, and then print out the answer in that format. Okay, so let's pinch this. Okay, and we'll open additional formula. Let's just close that one because I don't think we need that anymore. And then I'm going to paste in the question, or the challenge, sorry. So let's do our first user prompt. So give the first number, then we need an integer. So scanner.next line, and then open and close parentheses. Let's system out another one, so give the second number. Then int second input equals integer.value of scanner.next line. Oops, forgot to put my semicolon on. And then we can do, what if I spelled integer wrong? So we can do our final system out, and then what we're going to do is first input, and we're going to concatenate it. So plus second input plus equals plus, and then I'm going to do first input plus second input. Let's delete this. So we should get hopefully what we need. So it should be the first number plus the second number equals, and then our answer. Excellent, so that worked first time, that's great. So we can OK that one. So the next quiz looks to be a multiplication one, so I want to keep this open just in case I can reuse any of this code. So give the first number, give the second number, and then print out the answer. Okay, so I'm going to not copy and paste it because that would be bad. The idea is that we're learning, so I'm going to write it out, that's fine. I am going to copy this because if you haven't realised by now, my memory is atrocious. So let's close this. Let's open this one. I'm going to paste this in here and I will write it out, and then we can test it and see how we get on. Okay, so let's give this a bit of a delete and give it a run and see how we do. Put the wrong operands in, so I put plus and it's meant to be multiplication. So let's just go back in and change these. Oh, there we go, give that a run. And there we go, so we've got that one sorted as well. So I'll close that one down. Let's see what's next. Okay, so now we've got division. Once you've completed the previous exercise, try finding out the greatest possible multiplication that you can calculate. The reason behind the phenomenon you'll observe is that the value of an integer is capped at the maximum value of 2 to the power of 31 minus 1. This is because integer variables are represented with 32 bits in a computer's memory. Variable representation is covered in more detail on the computer organisation course. So division of integers is a slightly trickier operation. The types of variables that are part of the division determine the type of result achieved by executing a command. If all the variables in the division expressions are integers, the resulting value is an integer as well. So here we'd be expecting 1.5, but because we're printing out an integer and not a double, it is printing out 1. The previous example, print 1, both 3 and 2 are integers, and the division of two integers always produces an integer. So here we've got 2 integers again, with the double storing the result, and again we've still got 1 as an output, and that's because first and second, so these ones are integers. If the dividend or divisor, or both, of the division is a floating point number, the result is a floating point number as well. So double, when dividend is float, systemout.print, and you get 1.5, and here they've done it the other way around, and you get 1.5 as well. An integer can be converted into a floating point number by placing a typecasting operation before it. So here we've got the word double in parentheses, just there, and then it forces the value to be a double. The last example produces an incorrectly rounded result because the integer division is executed before the typecasting. The result of a division is assigned to an integer type variable. The result is automatically an integer. The next example prints 1.5. The dividend is converted into a floating point number by multiplying it with a floating point number prior to executing the division. So here, because we're multiplying it by a floating point, it becomes a double, and then the result is also a double. The next exercise tasks you with calculating the average of the entered numbers. Let's briefly review the concept of average. An average refers to the sum of numbers divided by their count. For instance, the average numbers 5 and 3 can be calculated with the formula 5 plus 3 divided by 2. Similarly, the average of numbers 1, 2 and 4 is produced by the formula 1 plus 2 plus 4 divided by 3. In the context of programming, there are a few things to keep in mind. Firstly, dividing by 0 is typically not permitted. This implies that calculating the average of 0 numbers is impossible. Secondly, if the program handles both the sum of the numbers and their total count as integers, one or both of the variables should be casted to a floating point number by multiplying it by 1 before the division. So write a program that asks the user for 2 integers and prints their average. So we're going to need to, or I'm going to need to pinch this. Let's go over here. So average of 2 numbers. Just looking ahead, the next one is average of 3 numbers. So I'll probably copy the code and then adapt it slightly. So firstly we need a prompt. I'm getting lazy with my naming now. So N1 is number 1. So we'll have a look and see if that works. So we've got the floating point number multiplied by the integers and then a division by 2. So let's give that a run and see what happens. Excellent, so we passed that one first time. So let's OK that. I am going to pinch this bit to save me having to write it out again. Okay, so we've got that open. Paste that in. Okay, and now we're moving on to the average of 3 numbers. So write a program that still asks for 3 integers and then prints their average. So we can take this code and just update it. So we can modify it slightly. Okay, so we've got our answer. So we've taken the code from the first part, just added another section, updated the answer, and then hopefully the printout will allow us to pass and move on to the next section. Okay, so I've got an error, which I've just noticed is because I did divide by 2 instead of divide by 3. So let's give that a run and see how we get on. Okay, so the last part is that I had hopefully the last part is that I've got that colon in there, so let's just give that a run. Excellent, so we've got a pass for this one as well, so let's close that down. Let's see if we have any more tasks today. So division, what does the program below print? So int 3 and 2, double result, but remember we've got the double multiplied by the floating point number. So let's see. So we've got dividend by divisor times 1. So let's see if it's 1.5. It's not, is it? It's 1. Because the floating point multiplication wasn't the first part, so they'd already done the division here with the integers and then applied the floating point. Okay. So here we've got a simple calculator. Write a program that asks the user for 2 numbers and prints their sum, difference, product and quotient. 2 examples of the execution of the program are given below. So they want us to take 2 inputs and then add them, subtract them, multiply them and divide them. Okay, I'm going to pinch this here and put that in my Netbeans. So let's open a simple calculator. Just seeing here that we're on number 23, I can't believe we've done that many already. So let's paste that in here. So the first thing we're going to need are some inputs, or some prompts for input, sorry. So give the first number, then we're going to need a integer to store the number. So I'm going to do int n1. Okay, and then we need our second prompt. Oops. And our second integer. And then we need to do our system outs. So let's delete this. So we're going to need system out. So it's going to be n1 plus 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 n2 plus equals plus n1 plus n2. But remember, you don't need to necessarily do it this way. You can always do yours store it in an answer. So we could do int answer equals n1 plus n2, like that, and then you can print out the answer, which I probably will do for the floating point one on the end. What have I done wrong here? So we got n1 plus all our pluses. There we go. So let's do, what I'm going to do is copy this line. So if we go to the end of the line, hold Control and Shift on our keyboard and press up, it duplicates the code for us. And then I'm going to go in and then change that to a minus, that to multiply, that to divide, and that I'm going to change to a minus, that to multiply, do 1.0 times that divided by 2. So let's just give that a run and see how we do. And there you go. So we've got another one passed. So let's head back to when a computer executes program code, it does it one command at a time, always advancing exactly as specified by the code. When a value is assigned to a variable, the same chain of events always occurs. The value on the right-hand side of the equality sign is copied and assigned to the variable on the left-hand side, i.e. copied to the location specified by that variable. It's crucial for a programmer to understand that assigning a value to a variable always does the same thing. Here's three common misunderstandings related to assigning a value to a variable. Viewing value assignment as a transfer instead of a copy, so saying first equals second, has been executed, it's often assumed that the value of the variable second has been moved to the value of the variable first, and that the variable second no longer holds a value, or that its value is 0, for instance. This is incorrect, as executing first equals seconds means that the value in the position specified by second is merely copied to the place specified by the variable first, hence the variable second is not modified. Viewing value assignment as creating a dependency instead of being a copy operation. Once first equals second has been executed, it's often assumed that any change in the value of the variable second is automatically also reflected in the value of variable first. That is incorrect. Copying is a one-off event. It only occurs when the program code first equals second is executed. The third misunderstanding concerns the direction of copying. It's often thought that executing first equals second, the value of the variable first, is set to the value of the variable second. The confusion also manifests itself in situations where the programmer accidentally writes 42 equals value. Fortunately, IDEs provide support on this issue too. Perhaps the best way to understand a program's execution flow is through the use of pen and paper. As you're reading the program, write down the names of any new variables, while making a note of how the values of the variables in the code change line by line. Let's demonstrate the execution with the following program code. So we've got int first equals 1 plus 1, int second equals first plus 3 times 2 plus 5, then first equals 5, then int third equals first plus second, and then we're printing out first, second and third. So here we've got the corresponding lines. Crikey, I won't read through those, there's quite a lot. Let's have a look. So these are the calculation steps. This is how an interpreter would go through the work, or go through the code, sorry. And you can see on the right hand side how it's updating the value of the variables and creating new variables as well. There we go. Consequently, the return type void is because they're running the code in the main, and you can see here its return type is set to void, just in case you're wondering. So what does the program below print? Int second equals 32, int first equals 25, second equals 17, and first equals second. So if second is equal to 17 and first is equal to second, I would like to think it's this one. Perfect. Excellent. That's another section that we've completed. We were really whizzing through these. So the next section is looking at conditional statements and conditional operations. So that's going to be looking at different types of loop and if statements and things like that. So that's going to be really quite an interesting one to look at. As always, thank you very much for watching and taking the time out to look at these videos. If you wouldn't mind subscribing, that would be really great. That would be really, really appreciated. And give me a little like as well. And if you can share the content too to any of your friends and family that might be considering starting a programming course, that would be really, really appreciated. Thank you very much. Happy coding, and I will see you for section 6.